Hey everyone, welcome to another episode of Darshan Talks. I'm here with my friend and our frequent guest at this point, Jim Nasr. And Jim has been with us and been on the show multiple times. We actually at one point talked about doing shows together. That's how often he was on. Eventually he realized that he prefers having a life. So he went and he's conquering the world. He is our friendly neighborhood global domination data expert. And I'm going to let him introduce himself for everyone. But Jim Nasr, Jim, introduce yourself.
Thank you for the welcome and thank you for unbanning me, Darshan. I think after last time you're like, Dash, I'll be suspended for a year. So the year is up. It's good. I'm glad to be back. And Happy New Year to you and everyone.
Happy New Year.
Fun things happening in all of our worlds.
Yeah, well, first of all, Happy New Year. And the New Year 2023 has brought with it the advent of artificial intelligence. And I don't know, do you follow Ray Kurzweil? Do you know who that is?
I do, yeah. Not religiously, but I certainly, yeah.
Yeah. I mean, that's the extent of which I follow him as well. Like, I've read about him, do a little bit of reading on him. But the big thing he was talking about a long time ago was this idea that in 2000, there'd be a computer that can defeat a human being in chess. And then 2012, you'd have digital assistants. And you got Siri and you got Alexa and you got all those other digital assistants at that point. He then predicted that by 2020, there'd be a computer that's as smart as an ant. 2023 or 2025, a computer that's as smart as a human being. And then 2050, a computer that's as smart as all human beings. And the reason I'm saying all of this is because, and I may have the dates wrong, but this was approximately where those numbers were. And that final point, I forget what it's called, but it's not sentience, but the singularity. At that final point when a computer is as smart as all human beings, is the singularity. And the reason I'm saying that all of that is because in 2023, we saw the advent of artificial intelligence. People have been talking about this for now, at least the last decade. And you're seeing the first version of that. My first question, before we even get started, is ChatGPT 3, which everyone's talking about right now, is that even artificial intelligence, or is it basically a chatbot? And what's the difference?
Yeah. So there's a lot to unpack there. And, people will blame me for being verbose. So I think it's your questioning that leads to verbosity. But is it AI? Yes, it is. It's more than just, kind of determined, like pre-programmed deterministic responses, right? Which I think I at least largely associate to chatbots. There's a lot more to it, and I think what was becoming evident as capturing people's attention and imagination is that they have taken, trillions of pieces of information around all kinds of things, texts and literature and all kinds of things, current news, current affairs, images, whatever, and I've made it very, very easy for the mere mortal like you and I to use simply, right? Because AI has been around for quite some time, right? This is not new. This capability isn't new. What's new is for Darshan and Jim to be able to hop on, and use, these technologies or like a news search like you.com, in seconds. That's what's new. And so I think that's exciting. That is AI, and it's just getting better and better because they're able to simulate information at massive pace of massive volumes, and the algorithms are that there's a lively community that's building on it, and it's open source. So it's kind of the adage of winning begets winning. So it's real. I think what's the possibilities are almost endless. But from you and I perspective, things like Siri and Alexa and anything that we've seen assisting us. They will only get better. They'll get more personalized. They will understand our context. They will know our background. The more you feed these, the more I think, the more they're going to adapt their responses to what we are. Now, if you follow it to its natural possible conclusion, that can be pretty darn scary because, again, you and I are in the world of compliance and HIPAA and things like this. Very, very quickly, that could become privacy invasive. That could become that could lead to unethical usage. All of us, we all kind of, as humans, we follow system A. We like the fight, flight, easy without having to really think. But if you kind of put your system B and deep thinking and long thinking aside and allow your smartphone to make all the decisions and the underlying AI to basically influence everything, well, a lot of bad things can happen. So I can kind of foresee that happening. Is it going to lead to evil computers running the world? I don't think so. I think that there's going to be checks and measures. But will it lead to micro implosions? Yeah, I would say for sure. I mean, I think it's already happening. You're already seeing with deep fake, these videos, you're already seeing all kinds of data. And I don't know how many, I feel like almost every day I get 10, kind of fake AI created LinkedIn profiles that, try and, hey, join your network. So all these images, all these people, all of which is generated, in seconds by AI. So yeah, I think we got to be aware of it. I'm more optimistic for more ethical usage within some boundaries. But I mean, as we've seen in our world of healthcare and pharma and things like this, and some of the new innovative technologies, regulators are woefully behind. I mean, they can't even get a speaker nominated, much less be on top of what's going on here. So that's a really scary thing because they're going to be reactive, they're going to be reactionary, they're going to I mean, it's already very evident that they're going to really struggle understanding how to help us kind of be able to consume it and use these things in a way that doesn't become a predatory situation for some of us. So good and bad.
I want to start from the beginning, though, of something you said, because you are so verbose. So there's so much to unpack there. But you mentioned AI's been around forever. The first one I can think of that was at least commonly used was Watson. And that was sort of, for those people who don't remember, that was on Jeopardy. And I think Watson won, if I remember correctly. Or maybe it got beaten pretty closely. But and everyone was amazed by it. And then what we landed up with was a scenario where they tried to take that technology and apply it to a bunch of different use cases, one of which was healthcare. Last thing I heard about Watson, probably about 4 years ago, was IBM shut it down because there just wasn't enough of a market there. Ooh. So what I'm hearing, though, is that AI's been around for probably about 10 to 15 years. But useful AI has definitely not been around for even 4. So what is the difference between AI now versus AI 4 years ago? What changed?
I mean, again, I'm quite pedantic about labels and things. I think AI has been around, since the 70s and even before, if you want to really go to the origin. And technology like Linda back in the day in the late 70s and early 80s, and even Steve Jobs and co were messing around with that stuff. And certainly in academia and academic circles, it's been around in various forms and evolving for quite some time, and algorithms have been. I think, the genesis of a lot of why all of a sudden AI is or machine learning, all this stuff is so easy to get to, and perhaps why Watson was as a project kind of decommissioned, is that you have some critical underlying things going on. One, we effectively have unlimited storage. Through cloud, anybody, you and I can have unlimited, we can have as much storage as we want. It's dead cheap. 2, we have unlimited processing power. Again, through cloud, through decentralized machines working together. That certainly was not the case even 15 years ago, never mind 30 years ago. And machine learning, artificial intelligence require that. Third thing is to be able to tie these two things, unlimited processing, unlimited storage, to essentially unlimited amount of data. Which again, as the world has become digitized, that digital data exists. 30 years ago, it will be a huge amount of work to take all this all the encyclopedias and everything and digitize them and make them OCR, kind of OCR, so you could read the text. But now all that really is native digital. It's just happening. So you got these factors, and then on top of it, you have really the ability for people like you and I to create brand new digital data, essentially out of nothing in moments, like through our smartphones, through our IoTs and Apple Watches and all this. So all this amalgamation of data and new digital data is being created. It's all going to the cloud. A lot of it can be made available to these algorithms that really, a lot of them have been around. What hasn't been around is trillions of data pieces readily accessible in a machine readable format, which it is now. So it's not magic, but when you and I are able to use ChatGPT, it's not like it was just something that happened the last few years. I think what's happened in the last few years is that it's become retail ready. It's become cheap enough, it's become pervasive enough, it's become usable enough that you and I can use it, and we're like, oh, this is cool. But it certainly wasn't an overnight thing. And I think, like I mentioned, cloud, unlimited bandwidth, unlimited storage, unlimited processing power. These are the kind of underlying, kind of pillars that have led to us being able to do, U.com and ChatGPT and things like this, anytime we want to.
So it's interesting. You talk about what's changed is not the technology; it's the information it can actually work off of.
Not so much technology. It's the underlying concepts and algorithms and things like this, like the methodology for a lot of AI and machine learning, it's evolved, but it's not like all of a sudden last year somebody, kind of just came across concepts behind deep learning, right? It's been around.
Okay. Well, the reason I raise that is because what that takes you to is you need to start talking about the data on the basis of which is forming the AI. And you and I had a very brief conversation before we jumped on about the concerns associated with that data. Because, for example, if you take public data and you just sort of work through it and you process it, you might be able to re-identify people who were originally de-identified. And this is a valid concern. The EU actually considers that in its policies. But I don't know of another country that actively denounces such, I might say another country or any another country bloc, that actively denounces this. What is the current status on getting ethically obtaining data, ethically processing data? Is there anything out there that talks about what data scientists should and shouldn't do? Is there anything we should be holding data scientists to?
Again, that's it's loaded. There's so much in there, and I certainly don't want to project my world and what we do to every industry and in every region or whatever. So I'll focus on healthcare, public health, pharma world. That's what we, patient data, things like this, where we know. There's definitely a regulatory angle, there's a compliance angle, there's a reporting angle, in our world of pharma, as example, for developing drugs and whatever, there's all this documentation, 21 CFR 11 and everything else that's fed into the FDA and all of that, right? And certainly preserving patients' privacy and not putting data in a place where it could be kind of reverse engineered or de-engineered to reveal personal information is huge, right? I mean, you and I spent quite a bit of time working on projects where we, took, the DISC industry standards and wrote algorithms to take personally identifiable data and create, ranges for ages and conditions and this, that, the other, so that data could be used in studies, right? So, but I think with AI and again, going back to unlimited storage, unlimited processing power, and now almost unlimited training data sets, which is like the critical thing for accurate and responsive machine learning, is very, very, very possible to reverse it. And not only is it possible, it's already happening, in many different pockets. And so I think to your question though, is about what can we do about it? I think what we, going back to healthcare, I think two kind of very, very important things are always in my mind when I'm talking to clients, around data and how do you get it, where do you get it from, how do you transform it, how do you then do aggregation and things like this to then use it and maybe at a population level. One is data quality itself. Like, is the data reliable? And can you ascertain where it came from? Like, is there authenticity in the data, right? And that area is where we firmly believe we can use public network cryptography to using proven cryptography that's been around for a long time. So we say blockchain, distributed ledger technology, but it's not just that. It's really the larger cryptography space. Use that to essentially in an automated way behind the scenes prove that the chain of custody of data. Where did it start? Who touched what when? Were they supposed to? And then what was the changes? What were the deltas? That's been around, it's doable, but now you could do it cheaply, you could do it behind the scenes. So that's the first use case, is around data quality and assurance of data integrity. Second thing is around data sharing, right? So, okay, you have great data, but in our world, that's not enough. I mean, certainly healthcare, all data is pretty much siloed everywhere. And you need to share data with other researchers, with hospital networks and physicians and the FDA, you name it, all kinds of different entities. So you need to be able to share it. And then kind of gets in this area of ethical collaboration, ethical sharing, ethical access to data. So both of those are use cases that I think we have to be really aware of. And again, to me, when it comes to like the sharing angle, that's where we get into for instance, secure APIs, interoperability, following standards around like data sharing protocols, doing encryption on the wire, and encryption transport and things like this, but also again using technologies like blockchain and other kind of cryptographic technologies to basically show that as you hand off one data from one place to another, that is privacy preserved. That somebody hasn't added like a little bit of Trojan horse, additional data bytes for tracking data, that the consent of the original data owner, such as a patient, is being preserved. That if the patient didn't consent for you as a researcher to use it, that the data isn't used. That the anonymization and aggregation methodologies meet FDA compliance. All that falls into the data sharing thing. And in fact, just recently I've been working with a couple of public health agencies, federal and state, very much on those two areas. And we're making the case that, look, there is modern, pervasive, very, very secure and kind of provable cryptography that you can basically run behind the scenes. Imagine it as like plumbing, right? It just runs. You don't worry about it. You don't have to have patients or physicians getting to log into something to do it. It just happens. But all that allows you to have much more assurance on data quality and how it's being shared. So that's kind of the way I look at it in this kind of context. I think, these are the kind of advents that to me allow us to have some more, control isn't the right word, but at least provenance and traceability and show chain of custody of this information in the face of very, very sophisticated ways in which data could be manipulated, by people who maybe, are nefarious or have reasons to manipulate data.
So I'm going to dig in a little bit deeper into this topic before I move into another one. But this is something you mentioned before we jumped on, but it's kind of very relevant because you just mentioned it. The key piece of chain of data, chain of custody, if you will, is, and you said this earlier, which is, it's not about provenance, it's about traceability. What is the difference? Because to me, as a lay user, those are the same things. But there's a very specific meaning in mind you had when you said those things. So what does that mean?
So I think what I'm trying to do, and you and I had a little conversation earlier about kind of quote the crypto space versus cryptography. Because I think now, and this is really just being pedantic about labeling accurately, because the work, as example, that we do is in cryptography. Most people, when they hear crypto, they're thinking cryptocurrency. They're thinking, oh, FTX blew up. who the hell is Sam Bankman-Fried? Why did we lose $400 billion? Why is this guy getting away? And regulators, that's what people are thinking. Whereas when we're trying to build solutions, we're thinking, what is pervasive, publicly provable cryptography? So in this context, when people talk about provenance, data provenance, a lot of times I think it can become like, well, it's all about blockchain. It's all about like what does a blockchain do? And it's all about like supply chain and things like this, because many people have kind of heard it coupled and associated too directly, these topics. But whereas really what we're kind of talking about is, going back to the comment I was making about like data sharing, is this idea of chain of custody. So if you think about like government, I spent time at the CDC and early in my career, I did a lot of work with intelligence agencies and things like this. So this idea of chain of custody of records is hugely important. Who touched it? Who opened this case? Who touched it? Who read it? Were they supposed to? If they did so, were they compliant to like the user access and things like this? So chain of custody of and again, I take a simple example. Let's say there's a shooting, right? And the police is there, and then the case becomes federal. It goes to the FBI. Well, like fingerprints. If there's a bullet, and if there's like a fiber from clothing or things like this, all of those things are assets, and there's a very, very kind of like strict chain of custody rules on who touches it, what, when, things like this. In the world of public health, there's like loads of examples of that, but as example, like one that may make sense is around things like biospecimens or chemical weapons like anthrax. It's hugely important that who touched what, when, where they're supposed to, where they go. That chain of custody, I think, is not a blockchainy thing. It's not a crypto thing. It's really just how business works. This is how, like, in the world of healthcare, clinical research, as an example, we come across this. When you do medical writing, to prove that the compound has gone through all these different steps before it gets to the FDA and supporting the Drug Supply Chain Security Act, you got to show how things move from one place to the next, to the next, to the next, and they're compliant. And to me, that's the concept. But let's not get lost in like things that are like technology centric, like provenance. It's really more like what is actually happening at the industry level, at the business level, at the layman level. What I think of as analog, as opposed to like all this like nouveau, like digital terms or like very crypto terms and stuff like that. So, and again, to be honest with you, I mean, we all kind of get swept into some of these things. I'm sure I've made the same mistake of just like, using one generic label to kind of try and mean something specific, but really people get lost because what you hear is typically noise. And right now there's so much noise about crypto this and that and fakes, crap coin and scammers and all of this. And all of it, I mean, a lot of it is right on the ticket. I mean, and people have to understand it, but you can't throw out the baby with the bathwater, right? We can't confuse things like chain of custody, which is a thing that's existed for, decades, versus something like this, like a very like specific instance, using blockchain technology as example.
So what I think is important, and we're hitting the end of what we can talk about, but what I think is kind of interesting and valuable. So, and I feel like you've been dealing with the fallout of this just because of the type of work you do. But 2, 3, 4 years ago, one of the big things that we would talk about is how do we leverage DLT's distributed ledger technology to connect with and for example, pay patients who are involved in clinical trials. And we talk about doing that using things like Bitcoin, for argument's sake. Obviously, right now, Bitcoin and its brethren are going through its own sort of issues. But to your point, I'm not completely convinced that we're going to throw out the baby with the bathwater, even in the context of just cryptocurrency. I think that there is a appropriate use case for it, but I'm not sure it is what we imagined it was, and it's going to remain as ungoverned as it was. But I guess my question for you, looking back at this now, as someone who understands the space from a technical standpoint, what do you think we can do from a sort of one of the key things you talked about is data quality and data authenticity. These guys were experts in that space. They were doing it in a specific use case, but they understood data quality. Why did they have such fundamental flaws in their financial structure that could not have been addressed from a cryptography standpoint? Sorry, not from a data standpoint, where you could track and understand where the money was flowing and all those. Does that question make sense?
Yeah, it does. I mean, I'm going to be, a little bit flippant with this, but it's not really a technology or data problem, or what technological measures could or could not have been used. It was really about governance. It was really about how things were run. At the end of the day, I mean, you could have the very best, let's take a car metaphor. You could have a Ferrari that can go like a rocket, but you don't know how to drive.
Right.
I mean, you can't do a thing with it, or you're going to crash it. And I think that the big issue here was, and unfortunately still a little bit there, you can kind of see it in some of the Twitterverse. There is, again, I'm not going to make a general statement, but there was a lot of lack of governance. There were a lot of people, who, for whatever reasons were in these positions, and some of these big VC firms really kind of like, propelled them, and there was a lot of like this pump and dump, but really it's a governance problem, right? And in fact, take the FTX situation. I mean, the guy said it himself many times. I mean, they really didn't even know their business. So it had nothing to do with the underlying technology or algorithms or none of that. So at the end of the day, and sometimes it's not even a question of were they being nefarious and intentionally trying to scam people. Is the fact that they just didn't keep an eye on things, or there were not enough checks and measures, and I think that's a story as old as time, right? I mean, that's happened many times. But also, honestly, I think in the crypto space specifically, the opportunity that one of the key underlying themes, has been, in fact, to some degree, still continues to be fear of missing out. And these people there are a lot of scammers that honestly take advantage of this psychological kind of, this human psychological need of not missing out. And the more people like, influencers and celebrities and Shark Tank people got on TV and talking about all this stuff that they barely knew anything about, the more people were like, wow, how come this guy made, 10,000 times, his money, and I'm not doing that, because I think you get all these people shilling on YouTube saying it's never too late, get in now. So you're fearing missing out, and I think that's a big part of it, and that allowed in some ways for people to, some people to get away with really just outrageous scams. In the meantime, going back to the comment we're making about regulators, I mean, just woefully behind. And I think now, and your comment, I think, is really very insightful. There is utility for token economics. There is utility for some cryptocurrencies, and there's utility certainly for blockchain, distributed ledgers, and things like this. But there's also a higher risk of over-regulation, reactionary kind of like government and societal backlash, where now you're going to kind of like stifle things that could be of value, could be of utility, could be infrastructure. So that's a worry for sure.
Jim, we are as usual past time because you are such a verbose speaker. Any parting words?
I think that's a euphemism for boring, but okay, I'll take it.
No, it wasn't for sure. But again, thank you for coming on.
Yeah, it's good. It's great to reconnect with you. There's so much. I mean, every one of these topics that we talked about, we could spend hours. Not necessarily just you and I, but in general, it's a space worth exploring. I think this AI stuff is important. As people are beginning to see the opportunity. Certainly the crypto stuff. Our world of pharma, public health, global health, healthcare. I think more than ever we got to be. I mean, I'm just outraged at how bad we are in the U.S. In all of that. I mean, it's insane. It's insane that the director of the CDC has to do a mea culpa, about all the things that were broken during COVID, and to me that really saddens me, because there's United States spending 20% of its GDP on this stuff, and the returns we're getting are so just so poor. So all to say, people like us should be part of the answer, not part of the problem.
I love it. Thank you again, Jim, and I hope to have you back, and we'll discuss some more.
Sounds great.